Okay, so welcome back, and now we're going to do some examples. Two of these examples we've seen before, so it'll be familiar. And so what we're going to do is we're going to decide what types of discontinuities we have looking at these functions. Okay, so now, if we look at this example here, we can see that there's a discontinuity at x equals 2. Okay, but what type of discontinuity is it? In this case, it's going to be a removable discontinuity. Remember what we discussed before. So what I'm going to do is I'm going to try to remove this by getting rid of where the discontinuity happens, which is at x equals 2. So what I'm going to see is, can I factor the top to get rid of this factor on the bottom? And the answer is yes, of course. We've done this one before, right? So we got x minus 2, x plus 2 in the numerator. We got x minus 2 in the denominator. And then, of course, these two factors cancel out, and we get x plus 2. And we see that now the discontinuity is gone. And so this is a removable discontinuity at x equals 2. Okay? Now, what about this example here? Okay, so this type of example, again, we've seen this before. At x equals 3, there is a discontinuity. There's a jump discontinuity. How do we know this? Because both limits from the left and the right exist, right? So at 3, we know the limit as x approaches 3 from the left, or the negative side, is going to be what? It's going to be negative x squared plus 4, which we found that is equal to negative 5, right? And the limit as x approaches 3 from the right is going to be this rule, which is going to be 4x minus 8, which we know is going to be positive 4. Okay? And notice that these two limits are not equal. So this satisfies part number 2 of the definition of a jump discontinuity, right? So far, this is removable. Okay? It's not defined at 2. Remember, so it's not defined at 2, but the limit exists at 2, right? So f of 2 is not defined here, but the limit exists. Okay? So it's removable. Oh, let me say that. No. Yeah, it does. It's undefined, and we're able to remove it. Okay? And then, of course, this one here, we already went over. Now, the last one here, they want to know, in this function here, they want to know, hey, is this continuous at x equals negative 1? And if it isn't, what type of discontinuity do we have? So obviously, we could see by plugging in negative 1 here, we get 0 in the denominator. So we know that there's a discontinuity going on. Now, the fact that, again, I'm just talking to you, so the fact that we get 0 here and we get a real number in the numerator tells me that automatically this is going to be an infinite discontinuity, because we don't get 0 over 0, right, like we do up here. Okay, so, and I can't factor anything. So there's something going on at x equals negative 1. Now I suspect that it's an infinite discontinuity, and what we're going to do is we're going to look at the left and right-handed limits again, or sided limits. Okay, so if we take the limit as x approaches negative 1 from the left, okay, of x plus 2, x plus 1. Okay, now, here's where you have to, again, you're going to have to slow down and think about what's going on as you get closer and closer and closer to -1 from the left, which means you're going from -3 to -2, -1.5, -1.4, -1.1, -1.01, and so on. So you're getting closer and closer to -1 from the left. So we know the top is getting closer and closer to what? 1. So we know that the top is approaching 1. It's a positive 1. Now, what's happening to the bottom? Well, we know the bottom is going towards 0, but what's going on here? Well, we're putting in values that are less than -1, which means that if I'm taking something that's slightly less than -1 and I'm adding 1, that means this bottom number is going to be negative. So it's a negative number that's getting closer and closer to 0. So if the top number is going towards a fixed number and the bottom number is going towards 0, we know that this is going towards infinity, because as this is getting closer to a fixed number on the top and the bottom is getting closer to 0, we know that this fraction is getting bigger. But is it getting bigger negative or is it getting bigger positive? Well, that's where we have to think about. The top is going to a positive number. The bottom is negative but getting smaller. So this thing is going towards negative infinity. Okay. Now, at this point, we can call ourselves done because we just showed that this is an infinite discontinuity. Okay. We don't have to check the right-hand side at this point, but let's do it anyway. Okay. So the limit as x approaches -1 from the right of x plus 2, x plus 1. Okay, now, same kind of thinking, okay? Again, as you're approaching -1 from the right, the top is still going to 1, right? So that doesn't change. But now what we're doing is we're approaching -1 from the right, which means we're adding numbers like 0, -0.1, -0.2, -0.3, -0.9, -0.99. So we're getting closer and closer to -1, but we're approaching from the right, which means this bottom is going to be positive. Okay, because we're subtracting where the bigger number is positive, so the bottom is going to be positive, but it's getting smaller. And so since the top number is, the numerator is going towards a fixed number, and the bottom number is getting smaller and smaller but positive, it's going to positive infinity. And again, that just shows us that we have indeed an infinite discontinuity. Okay? Have a great day.